So today we are reacting to an interview that David Bombal did with Tom Kelly, who is the Chief Technology Officer over at Penduit. Now, before we go any further, this is not a critique of David Bombal. Quite the opposite. David is one of the most respected educators in the networking industry. And I've learned a great deal from his content over the years. And if you are interested in networking, there's a very good chance that you have watched one of his videos as well. But during this interview, something was said that made me stop and think. And that's the reason for this video. Because if you've ever been told that CAT7 is the future, and I've heard this from vendors before, or that you should always buy the highest category cable that you can afford, then there's a very good chance that you've been sold an idea rather than an engineering solution. I have a feeling this video is going to upset a few OEMs and cabling vendors and marketing departments. And honestly, I'm okay with that. Because today we are finally going to say the quiet parts out loud. Let's react.
I've heard that CAT7 is a scam.
Whoa. Okay, so there's some fighting words there, David. No, I'm just kidding. So he's right and he's wrong. Because the truth is considerably more complicated.
Yeah, I'd say it's not a scam. It's a standard that exists.
Good, because that's exactly where we need to start. CAT7 is real. It's an internationally recognized standard. And just as a quick FYI to bring everybody to speed, Ethernet cables are divided into performance categories based on bandwidth and data transfer speeds and maximum transmission distances. And the most common modern standards used for local area networks and internet connections range from CAT5e to CAT8, each providing different levels of signal integrity and interference reduction. So if someone tells you CAT7 doesn't exist, they're simply wrong. But here's the twist. Just because something is a real engineering standard doesn't mean it's the right product to buy. And that's where the story gets really interesting.
But can you take advantage of the available bandwidth? I think the answer to that's no.
So I'd answer that a little differently. Technically, the cable can. Practically, you usually can't. And that's an important distinction. People often think that buying a better cable automatically gives them a faster network. It doesn't. Your network is only as fast as the slowest part of the entire system. Your switch, your network card, your connectors. The Ethernet standard you're using, the cable is just one piece of that puzzle. So if you look here, you'll notice something interesting. CAT6A is rated up to 500 MHz and CAT7 increases that to 600 MHz. So on paper, CAT7 actually has more available bandwidth. The real question isn't whether the cable can support it, it's whether the rest of the equipment knows how to use it. And that's where the story gets really interesting.
So in other words, if a salesperson is trying to sell me CAT7 or CAT8, I shouldn't listen to that person. I should get CAT5.
CAT5? No, David, this is not 2009, my man. Okay, but seriously, we all love CAT5e. It's cheap, it's easy to terminate, and for gigabit networking, it still does a perfectly good job. But, and this is a very big but, CAT6A has become so affordable and with the right tools almost as easy to install that for most new installations I'd struggle to recommend putting in legacy cabling today. Why install yesterday's technology when tomorrow's technology costs only a little more? Of course, if you happen to have 5,000 meters of Cat5e sitting in your storeroom, I'm definitely not judging anyone in the room.
Probably CAT6A.
Okay.
So CAT6A is 10 gig transmission.
Now, this I completely agree with. If you asked 100 experienced network engineers what cable they'd install in a new commercial building today, I'd bet the vast majority would say CAT6A. But not because it's the newest, and not because it's the highest performing, because it's the sweet spot. CAT6A was specifically designed to support 10 gig Ethernet over the full 100 meter channel. And that's an important distinction. Yes, CAT6 can also support gigabit, not CAT6A, CAT6, but only over shorter distances, typically around 55 meters depending on the installation. And CAT6A gives you the full 100 meters defined by the Ethernet standard. This is very, very important to know. And that's one of the biggest reasons it's become the industry's preferred choice. So engineering is often about finding the sweet spot. Not the cheapest, not the most expensive. The point where performance, compatibility, reliability and cost all come together. And for most structured cabling projects, that is CAT6A. It's a bit like a Toyota Hilux. Is it the fastest vehicle you can buy? No. Is it the most luxurious? Also no. But if you asked thousands of engineers what they trust to get the job done every single day, you'd hear the same answer over and over again.
It's ubiquitous. You can plug an RJ45.
I completely agree. And I think that single word, ubiquitous, is actually one of the biggest reasons CAT6A became the industry standard that we see today. Not because it's the fastest cable ever made, not because it's the newest, but because it's everywhere. Every major switch manufacturer supports it. Every major network card manufacturer supports it. Every structured cabling manufacturer makes it. Every installer knows how to terminate it. Every cable tester knows how to certify it. And if something goes wrong 10 years from now, finding replacement parts won't keep you away at night. So one of the biggest lessons in engineering is that the best technology doesn't always win. The technology that's easiest to deploy, easiest to maintain, and the easiest to support, that is so important, usually does. And that's exactly what happened with CAT6A. It became the sweet spot between performance and cost and compatibility and long-term reliability. We can actually certify our CAT6A sites with the right vendor for 10 years. That is crazy. So for the vast majority of new commercial installations today, it's still an excellent choice.
Connector into a switch and a server, and you can get 10 gig transmission.
So I think that's exactly the key point. Not the cable, the connector. And more importantly, the entire ecosystem built around it. You see, RJ45 has been the king of Ethernet for decades. It's on your laptop, it's on your desktop, your switches, your servers, your patch panels, your wall outlets. It's everywhere. And that's why CAT6A became such a success. You could install it today. You could plug it into virtually any modern networking equipment, and it just works. No special connectors, no special hardware, no special tools, just a mature, proven ecosystem. And that's incredibly valuable in engineering and network building.
So I think that's really the key point to focus on. There's available bandwidth in those other standards, but you really can't tap into it.
So I think I'd phrase that a little differently. The cable isn't the real limitation. the ecosystem is that I've mentioned just now. So CAT7 was designed around connectors like GG45 and Terra, which offers some genuine technical advantages. The problem was the rest of the networking industry had already committed to RJ45. Switch manufacturers, service manufacturers, network card manufacturers, everyone kept building around RJ45. And once that happened, the battle was effectively over. Because in engineering, compatibility is often more important than perfection. A technically better solution doesn't always become the industry standard. The solution that everyone can actually use usually wins.
Because you don't have a connector interface or a board mount connector to get 40 gig transmission over twisted pair.
So this is where the story gets really interesting. Because technically 40 gig Ethernet does exist over twisted pair. The standard is called 40 GB base T. The problem isn't that it couldn't be engineered. It's that the industry chose a different path. So by the time 40 gig networking became practical, data centers had already embraced technologies like direct attached copper and active optical fibers and fiber optics. Why? Because they offer low latency, lower power consumption, greater distances, and a much clearer upgrade path to 100 and 400 and now even 800 gigabit Ethernet, which is crazy if you think about it. So instead of investing billions into making twisted pair Ethernet faster and faster, the industry simply moved on. And that's why you'll almost never walk into a modern hyperscale data center and find rows of CAT7 cables carrying 40 gigabit traffic. You'll find fiber, lots and lots of fiber. Sometimes a technology doesn't lose because it wasn't good enough. It loses because another technology solved the problem even better.
Okay, so in other words, I can't have an Ethernet network card in my gaming computer that actually allows me to use the capacity of that cable. I might as well just buy 6A, is that correct?
Yes, exactly. That's probably the best advice in the entire video. Thank you for that, David. So if you're building a gaming PC today, buy CAT6A and spend the money you saved on a better graphics card, not a cable.
That would be my recommendation, yes.
So in the real world today,
Yeah.
if I as a network engineer was deploying cable, 6A would be the answer, or what would I choose?
6A is the answer.
Yes, without hesitation. If you ask me to design a new office or a school or a warehouse or even most commercial buildings today, I'd specify CAT6A immediately. Not because it's the most exciting option, not because it's the most expensive, because it's the right engineering choice. It supports 10 gig Ethernet over the full 100 meters. It uses the universally adopted RJ45 connector. It's supported by virtually every networking manufacturer. It's proven, it's reliable, and it's likely to remain relevant for many years to come. Could you install CAT7? Absolutely. Should you? In most cases, probably not. No, actually. So engineering isn't about chasing the biggest number, it's about choosing the most appropriate solution. And for the vast majority of installations in 2026 and beyond, that solution is still CAT6A.
Because it gives you 10 gig transmission, it's ubiquitous, it's available everywhere. You can plug it into servers and switches and laptops and access points, and it's fit for purpose.
Exactly, and that is why CAT6A became the industry standard. It works, it's proven, and perhaps most importantly, everyone supports it. Sometimes boring is brilliant.
Can you go into the nitty-gritty of the differences between CAT6 and 6A? Like, why would I buy 6A, not 6?
That's actually a fantastic question. And fortunately, the answer is pretty simple. Both are excellent cables, both support gigabit Ethernet, both use the same RJ45 connector. The biggest difference is distance. CAT6 can support 10 gig Ethernet, but typically only to about 55 meters, depending on the installation and the environment. CAT6A was specifically engineered to deliver 10 gigabit Ethernet over the full 100-meter channel. Again, that is very, very important to know. It also offers better protection against interference and something called alien crosstalk. It's not as exciting as you may think it sounds like. And that's interference from neighboring cables in large cable bundles. And we've struggled with alien crosstalk in the past, especially from other installers, a lot, up to the point where we have to reinstall the whole thing because it's so messed up. So CAT6 is absolutely fine, but if you're designing a commercial building or installing new infrastructure that you expect to last the next 15 to 20 years, I'd spend a little bit extra and install CAT6A. Because replacing network cable later is a whole lot more expensive than buying the right cable the first time.
Yeah, so I think you really got to key in on the application layer.
Absolutely. This is very, very important. Start with the application, then choose the cable, not the other way around.
So think about 1 gig applications and 10 gig applications, and then this thing called multi-gig applications. There's the cabling standard, 5E6 and 6A, but I think you should really focus in on what's the data rate of the application running on the infrastructure.
I couldn't agree more. And if you're wondering what multi-gig means, it's simply Ethernet speeds between 1 and 10 gig, typically 2.5 and 5 gig Ethernet. And it was introduced because many existing Cat5e and Cat6 installations were perfectly capable of carrying more than 1 gigabit without the expense of replacing all the cabling. Now, this is exactly how network engineers think. You don't start with a cable, you start with the application. What speeds do you need today? What speed might you need 5 or 10 years from now? Then you choose the network equipment, and finally the cabling that supports it. So the cable is there to enable the application, not define it. And that's probably the biggest lesson from this entire discussion. Don't buy the cable with the biggest number. Buy the cable that's right for the job.
And so think 5E is 1 gig. Cat6 can be multi-gig. Sometimes you'll see 2.5 gig or 5 gig. That's the Cat6 domain.
Exactly. Think of it as matching the cable to the speed you actually need. Cat5e for 1 gig, Cat6 for multi-gig, and Cat6a when you want reliable 10 gig over the full channel. Now that's good engineering.
And then category 6A is 10 gig.
Spot on. That's why Cat6a has become the industry workhorse.
And so you have to kind of marry the cable standard to the application that you intend to run.
Exactly. Good engineers don't choose cables, they choose solutions. Write that down.
And that calls into, the equation, the active equipment, the server and the switch and the endpoint, and what transmission can they do.
Again, spot on. A network is only as strong as all of its components working together. Your switch, your server, your network card, your Wi-Fi access points, and your cabling all have to support the speed you're trying to achieve. You can't install a Ferrari engine into a family hatchback and expect it to become a Ferrari. That would be awesome, actually. Networking works exactly the same way. Design the entire system to work together and you'll end up with a network that's fast and reliable and won't cost you money fixing it later.
And then choosing the right cabling to achieve that data rate that you're after.
Absolutely. Build the network around the application, not around the cabling. So what are the key takeaways here? Well, first, CAT7 isn't a scam. It's a real international cabling standard. The problem isn't the cable, it's the way it's often marketed. And second, don't buy a cable because it has the biggest number. Buy the cable that's right for your application. And for the vast majority of new commercial installations today, that is still CAT6A. And finally, if you really need ultra high bandwidth, don't look at CAT7 or even CAT8. Look at fiber. That's exactly what hyperscale data centers do. Once you go into 100 gigabit and 400 gigabit and now even 800 gigabit Ethernet, twisted pair largely disappears and fiber takes over. Because sometimes the right answer isn't a better copper cable, it's a completely different technology. Engineering has never been about buying the most expensive solution. It's about choosing the most appropriate one. Bigger isn't always better. Better isn't always better. Sometimes the best technology loses because compatibility beats perfection. So if you enjoyed this reaction video and would like me to react to more networking myths and data center discussions or digital infrastructure content, let me know in the comments below because I really enjoy making these. So I hope you enjoy watching them. And if you learned something today, give the like button a little tap. It might only support one click, but unlike CAT7, it's guaranteed to be universally compatible. And don't forget to subscribe for more videos where we separate engineering facts from marketing fiction. Until next time, thank you for watching.